To celebrate that we're going to talk about covariance today, I have a new blue sparkly pen. I found this in a classroom. It's great because it's got sparkles on it. Alright, covariance. The covariance functional measures the degree of linear association between two random variables. Okay, and we say it's a functional because it's a function of a function, or it's a function of functions. Okay, and remember that random variables are indeed functions. Remember, they map spaces of events or spaces of sets to a real line. And so the covariance function, or functional, the covariance of x and y will define to be the expected value of x minus the expected value of x times y minus the expected value of y. Okay. Hey, this looks a lot like the variance, right? If I replaced the y's with x's, then it would in fact be exactly the definition of variance. So this sort of reduces to variance if you take the covariance of x with itself, doesn't it? All right. So what the heck does this mean? Well, again, so it measures the degree of linear association between two random variables. Let's check out a couple of cases here. Let's say I have my x variable running along the horizontal axis, and my y variable takes on values along this vertical axis. Let's say I take some data points. Okay, I'm going to think statistically here. I'm going to actually go and get some data. Okay, or maybe these are points that can actually occur out of my joint distribution for these two variables. Okay. Let's see, the expected value of x in this case, let's put a few more points up this way. The expected value of x in this case is probably right about here, right? You know what I mean? If you dropped all these points down onto the x-axis, then where would you put your finger to balance them there on the x-axis? Where is sort of the middle of their horizontal positioning? It's right about here. Where's the middle of their vertical positioning, sort of? It's right about here, right? If you take those two coordinates, hey, this is the center of mass. Center of mass. Okay? Right? That's sort of the center of, in fact, we better color it red because it might not be actually a point in the system there. Okay? So in this case, note that above average x values tend to occur with above average y values. Okay? And if you take a look at this formula, you'll see that probably indicates to us that the covariance of those two variables is going to be positive. Take a look at this. It's the average, right? That's what E stands for. It stands for average of these products, right? The average, let's see, if x tends to be greater than its mean, then this is positive. And then if y at the same time tends to be greater than its mean, this will tend to be positive. Product of two positive things is positive. Or if x tends to be less than its mean, when y tends to be less than its mean, like we're down over in this region, okay, then you have the product of two negative numbers, right? Negative times a negative is positive again. Okay, so the average of a bunch of mostly positive things, you know, when you're having these contributions mainly from a region down here and a region up here, you're going to tend to get something positive on the average, probably, right? Yeah, so in this case, the covariance of x and y is going to be greater than 0. Okay? On the other hand, what do you think would happen if you had a situation like this? If I had my x variable running horizontally again, y running vertically, what if this point pattern of data, or the distribution for that matter, sort of runs this way? Okay, so that here's the expected value, the x values. I guess that's about right. And maybe the mean of the y values is, I don't know, it could be anywhere. It's like here. Okay. And again, I'm going to color that red. No offense to my wonderful blue sparkle pen, but just because we note that the center of mass here may or may not actually be a data point, or may or may not actually be allowed to be a point from the distribution. Okay. Now, notice that points with below average x values, right, here's the average x, these points over here have x coordinates that are below their their average in the x direction. They tend to correspond to having above average values in the y direction, right? So, in this case, the covariance of x and y will be negative. Okay? It's because above average values, above average x values, sorry, tend to occur alongside below average y values. Okay. What about this case? What if you saw something like this? If you saw something like this, you should run and hide. That's what you should do. Now, this just means that the covariance of x and y are probably it's probably close to 0, okay? Or it's low. I don't know what it is. It might be 2, or it might be 0.2, or negative 0.5, or negative 0.001. In this case, we say that the variables are uncorrelated, or that there is no association. X and y are not very correlated. They are not very associated, okay?